Scatterplots are used to visualize bivariate data when both variables are numerical. Now, bivariate data is a data set that consists of measurements or observations on two variables that we'll call X and Y. Let us follow a scuba diver as he records the depth and the pressure at that depth. He takes readings every 2 fathoms or so. So on the surface, you have 0 fathoms, which is the depth, and the pressure at that point is going to be 1 atmosphere, ATM. Down at 2 fathoms, the diver records the pressure at 1.5 atmospheres. At 4 fathoms, it's 2. At 6 fathoms, it's 2.8. At 8 fathoms, it's 3.6. This is the part of the data set that we're going to deal with. So therefore, we have a bivariate data. One variable is depth, the other is pressure, and they're both numerical variables. Now, the depth and the pressure at a particular point is called a pair, an XY pair. The depth will be the X number, pressure is going to be the Y number. So we have 5 XY pairs here. Now, an unorganized list of such pairs cannot give us much information about the relationship between the two variables. That is, do X and Y increase or decrease together? Does one increase while the other decreases? Or is there no relationship between them? Well, we cannot get this information by simply looking at the pairs of numbers. But a picture of the data or a graph or chart can be used to give us that information and more. Perhaps the most commonly used chart is a scatter plot. On this plot, we place the X scale on the horizontal axis and the Y scale on the vertical axis. The pairs of numbers will now be points on the XY plot window. Now, generally, if the points follows an upward sloping line, like they do here, now we say the relationship between the two variables is a positive one, which means that both X and Y will increase together or decrease together. If the points follow a downward sloping line, we say the relationship is negative, which means one will increase while the other decreases. If the points follow no particular pattern or line, then there's no relationship between the variables, and the variables are said to be independent. For our Excel demo data set, we're going to use the data from the study of a stag beetle. The stag beetles are a particular beetle found mostly in Southeast Asia. In this study, they measured the wingspan and the length of the thorax of 10 beetles. And here's the data. So we have a small numerical bivariate data set, and we're going to do a scatter plot of this data. Now here is our data set. But to get our scatter of this, we simply highlight, go to Insert, Chart section, you look for Scatter, and you choose that first option. And right away, you're going to get our scatter plot. Of course, we can then tweak the colors, labels, title, and all that stuff. If you have 2 sets of data, let's say a second species of beetles, that you want to have the 2 sets of data on the same scatter, where you have one set of dots in one color and the other in a different color so you can tell them apart. Now let's see how to do that. So in this section, we're trying to get 2 sets of data or 2 sets of points on the same plot. For our two sets of points. We have the HEI species and the HEP species, two species of stag beetle for which we have the wingspan and the thorax length. Okay, so we have to do a little coding here, a little light coding. So the first thing we do, we go to E1, let's say, or any cell up there, and you write HEI, the first species. F1, you write the species, which is HEP. Okay, now you go down here. What we're going to do, we're trying to get all the Y values, which is the thorax length for the HEI species, and the Y values for the HEP. So you have the first, let's say E2 and F2, you'd have the Y value for HEI, and for HEP, there's nothing in that first one. So you're going to have an NA right there. So all the Y values for HEI will be here, and here will be NAs. Now, when you get to HEP, which is A12, the first values, the first Y will be NAs, and the second will be HEP, so the second will have the Y values. In other words, in column E for HEP, there'll be NAs. In column F, you have your Y values for HEP. So let us get the little coding in. You don't have to understand this, just follow along and copy the formula. First thing we do, we put an equal sign, use the if function, open brackets. Now, you want to say, you want to make a comparison. If A2, what's in A2, which is HEI, is the same as in E1, in other words, if you're on the HEI species, so you put $A A2. If what's in A2 is equal to HEI E1, so you have $1. That's the comparison. You're comparing what you find here with E1, with what's in E1, which is HEI. So wherever there's an HEI here, we'll do something. Well, what are we going to do? We're going to enter the Y value of that particular observation. So you put a $sign C2. What's in C2? That's 15.4. And for the HEP side of it, this is not HEP, so you're going to have an NA. NA, open close brackets, and then you close the outside bracket. So that is what you got here. And you hit the enter, and you're going to have that Y value. And what you do is you come down to the bottom and drag it across. So HEP is going to have now an NA. So you have two Y values for each line, the HEI and the HEP. Of course, for the first 10 values, you're going to have HEI values and the HEP would be NAs. So now to get the other HEI values, you highlight both of them, come down here, and drag it down to 11th row, and you get all the Y values for HEI and NAs for HEP. Now the HEP begins here. So you got to get a different line of code. So you put an equal sign, use another if. Now this is A12. You're comparing with what's in F1. You're comparing what's in A12. So $sign A12 is equal to F $1. So if what's in A12, which is HEP, lines up with HEP up here, then you write something. You write the two Y values. So the first Y value, of course, would be HEI. So you're going to put an NA there because we're dealing with HEP, you see. And for the HEP, the second Y value, you're going to put whatever you find in C12, which is the Y for C12. It's $sign C12 and close it out. So of course the first would be the HEI, would be an NA. So you highlight that and move it across. Now the second value would be HEP. So you're going to get your 18.9. And now you sort of copy this down to the other HEP cells, drag down, and you're going to have NH in the first, in the E column now, and you're going to have the HEPY values in the F column. So now time to get our scatter plot. So what we do, of course, we highlight the wing, the X values, which is the B column, all of it, you highlight X. And then you hold down the control button and you highlight both the E and the F at the same time. You see, hold down the control, drag it across, and highlight the both columns. Now you just simply go to Insert, Scatter, choose that same first option, and you're going to get your scatter plot for two series now. You're going to have one with the blue dots and one with the orange dots. And here you have your legend. It's telling us that the blue dots will be the HEIs and the orange dots will be the HEPs. So this is how you get a scatter plot for two series of data. So this is how you do it. If you have data that deals with the value of a variable that changes with the passage of time, then the best chart for this type of data is a line chart. A line chart graphs numerical bivariate data, just as the scatter plot does, where one of the variables must be a variable of time for a line chart. This chart allows us to see trends by the ups and downs of the lines traced from one point in time to another. Our data set gives the average life expectancy for people living in country A from the year 1940 to 2000, recorded every 10 years. Now, to get a line chart, you highlight your data, go to Insert, go to Line. You can either select the first line and you get a smooth line like this, or you can select this one here where you can get a line with the dots representing the points in time. Now, we can graph multiple series of data with the line plot. So let us get another country B, and this is the life expectancy for people living in country B. So let us get the line chart that will contain the two series of data. So again, you highlight everything, you go to Insert, again you get the line. This is a smooth line. You have the top line is A, country A, blue. The second line is red, country B. If you want those dots representing points in time, change it, you can get that one, and you have the dots, points in time. Now, as with other charts, you can give the chart a title, you double click. Now we can look at the lines and kind of read what's going on. At each point in time, the life expectancy is at least 2 points higher than that of the red line, country B. Furthermore, you see that country B after 1980 life expectancy actually started to drop, whereas prior to that, it showed a steady increase. Country A, however, is showing a steady increase in the life expectancy throughout the time period. If you're not satisfied with the size or location of your chart, you can easily resize it or move it to a new location. We want to increase the size of this chart. Well, the first thing we do is click on it to select it. Now, these nodes are called sizing handles. You put the pointer on one of the sizing handles, let's say the lower left. Hold down the left mouse button and drag diagonally downwards to the left until the chart has assumed a size that you're happy with. In most cases, the chart will cover your data as it is doing right now. So you want to move it to a new location in the same worksheet. What you do is, you put your cursor on your chart, select it until you see the cursor becomes this four-headed arrow. Hold down your mouse button and drag the chart to whatever location you desire, then release. You can move the chart to a new worksheet altogether by selecting, right-clicking, clicking on Cut, going to a new worksheet. You click on a cell somewhere close to the top, right-click, click on Paste, and your chart has been moved to its own worksheet. Well, this is the end of this section. This is the end of the video, and we'll see you in the next video.